During this past 4th of July weekend, hackers aggressively attacked U.S. government and private websites.
This is a very serious topic because it could potentially do some serious damage and also expose information of your personal data.
To get the hang of the story, we need to go way back. In 1957, Russia stunned the world by becoming the first country to launch a satellite into space, known as Sputnik 1. This historic event marked the dawn of the space age and triggered a wave of anxiety in the United States. Imagine this. A superpower with unparalleled technological prowess had just leapt ahead in the most significant race of the era. For the U.S. government, this was a wake-up call that couldn't be ignored. Technological superiority, after all, often translates directly to military advantage, enhancing the capability to win wars with advanced weapons and strategic tools. Determined not to be outdone, the U.S. government sprang into action. Just 4 months after Sputnik's launch, they established a new agency, the Advanced Research Projects Agency, or ARPA. The mission of ARPA was crystal clear: spearhead the United States' technological innovation and research to regain the lead. This agency was tasked with solving the urgent challenge of designing and launching America's own satellites into space. However, in the aftermath of Sputnik's launch, considerable debate arose over where this new agency, ARPA, should reside within the U.S. government structure. Should it be part of the Department of Defense? The inclusion of defense in DARPA's name, Defense Advanced Research Projects Agency, reflects this debate. Ultimately, it was decided that ARPA would remain independent of the Department of Defense, largely due to public concern. Post-World War II, Americans were wary of an agency perceived to be focused solely on military interests, fearing it would lead to an arms race rather than peaceful technological advancement. To address these concerns and demonstrate a commitment to peaceful exploration, the U.S. government established NASA, the National Aeronautics and Space Administration, in 1958. NASA's sole purpose was to advance space exploration and scientific discovery, clearly separating its mission from military objectives. The government ensured that NASA was free from the Department of Defense's influence, calming public fears and garnering widespread support for space exploration. And ARPA's funding was redirected to support NASA's ambitious projects, fueling the race to space. So ARPA now found itself in a difficult situation. With much of its funding redirected to NASA, the agency needed a way to continue its mission of advancing technology. They came up with a creative solution: sponsor university professors across the country who were already conducting research in various fields. It wouldn't require a lot of money and would help keep critical research moving forward. However, as soon as they implemented this idea, they encountered a significant problem. These university professors needed powerful and expensive computers to carry out their research. While many universities possessed such computers, there was a lot of overlap in the research topics being explored. This meant that the same concepts were being studied multiple times by different groups, wasting both costly computing resources and human effort. If only there were a way for these professors to share their findings from their university computers with other universities, this problem could be solved. To address this issue, in 1966, ARPA initiated a groundbreaking project named ARPANET, which stands for Advanced Research Projects Agency Network. The goal of ARPANET was to connect all these powerful computers over a network, enabling professors to communicate and share papers, data, and other resources seamlessly. After several months of diligent work, they successfully linked these computers by assigning each one a unique number for identification. For example, if a computer with the number 8.2 wanted to communicate with another computer at a different university, it was as simple as inputting the number of the target computer, much like dialing a phone number. These unique numbers were called IP addresses, standing for Internet Protocol. Even today, every device capable of connecting to the Internet, whether a computer, laptop, or mobile phone, has an IP address. This number serves as its unique identifier, ensuring that data can be accurately sent and received across the vast network of the Internet. At the time, there was only one person managing this system, John Postel. If you wanted your computer to join ARPANET, you'd simply call up John and ask him to assign a unique number to your machine. John would then add this new number to his master list and share it with other computers on the network, informing them of the new addition. Because of this role, John became known as IANA, the Internet Assigned Numbers Authority. This process was tedious, but it worked initially because ARPANET only connected university and a few government computers. However, as more government offices began requesting to join ARPANET, the system started facing scaling issues. It became clear that people are not great at remembering long strings of numbers. Imagine if, every time you wanted to visit a website like Google, you had to recall and enter a 15-digit number to connect to Google's servers. Most people would struggle with this. The solution was obvious. Instead of using numbers alone, they decided to map each IP address to a human-readable name. John Postel continued to issue the numbers, but now each number was also mapped to a name that people could easily understand and remember. These names are known as host names or domain names. In a domain name, everything that comes after the dot is called the top-level domain, TLD. Initially, there were only 7 TLDs: .com, .org, .net, .int, .edu, .gov, and .mil. So if you wanted your computer on ARPANET, it would have an IP address mapped to a host name followed by one of these 7 TLDs. Around this time, personal computing began to explode. Ordinary people like you and me started owning personal computers and wanted their devices connected to the internet. ARPANET was no longer just a research project. It was evolving into what we now call the internet. It quickly became apparent that having a single person manage IP address assignments was not sustainable. To address this, an announcement was made. Anyone in the research community with a better idea for managing domains and IPs was welcome to share their thoughts. That's when a researcher named Paul Makapetris stepped forward with a revolutionary system. He pioneered a new way of managing domain names called the Domain Name System, or DNS for short. This system is still in use today. When you type any internet address into a web browser, the first thing it does is check its memory to see if it already knows the IP address of that website. This is called caching. If the IP address isn't cached, the browser asks your operating system. If the OS doesn't have the IP address cached either, the request then goes to your Internet Service Provider, or ISP. Your ISP has a server dedicated to these requests called a recursive server. The recursive server's job is to find the IP address of the domain you want to visit. Here's how it does that. First, the recursive server checks its own cache. If it doesn't have the IP address stored, it reaches out to a root zone server. Think of root zone servers as the top of the DNS hierarchy, knowing where to find information for all top-level domains. The root zone server responds with the address of the TLD name server responsible for the requested TLD. Next, the recursive server contacts this TLD name server. For example, if you're trying to reach example.com, the recursive server will contact the .com TLD name server. The TLD name server doesn't know the exact IP address of example.com, but it does know where to find it. It provides the address of the authoritative name server for example.com. Finally, the recursive server contacts the authoritative name server for example.com. This server holds the actual IP address of the domain. It responds with the IP address, which the recursive server sends back to your ISP. Your ISP then provides the IP address to your operating system, which passes it back to your browser. Now, your browser can connect to example.com and load the website. With the new system in place, the government broke a contract with a private company called Network Solutions. This company had been managing domain names. Things carried on like this for a while, but as the internet exploded in growth, the cost of handing out domains shot up. The US government couldn't justify paying so much, especially since most people registering domains weren't even US citizens. On top of that, conflicts started to pop up. What happens if someone registers a domain with a brand name like McDonald's? How do you know it's the real McDonald's and not some random person? Faced with all these issues, the government needed a solution, fast. Enter ICANN, which stands for the Internet Corporation for Assigned Names and Numbers. They were created to manage the growing chaos and make sure everything runs smoothly when it comes to domain names and IP addresses. The most important thing to know here is that ICANN isn't controlled by any one country. The people involved come from all sorts of different diverse countries. Every decision they make is run through their community, which, you guessed it, is also made up of people from all over the world. What does ICANN do exactly? Well, they're responsible for managing the root name servers. Remember those from earlier, which are the ones ISPs check to find TLD server addresses. They also make sure the internet stays secure and give private companies the status of registry. Registries are mostly private companies that manage top-level domains, TLDs like .com. In fact, right now, a private company called VeriSign handles everything related to .com. Any company can become a registry as long as they meet the criteria set by the ICANN community. Registries not only manage TLDs, but also set the initial price for them. Companies like GoDaddy and Namecheap, called registrars, decide how much they want to sell those domains for based on the price set by the registry. They also make sure no one else has already taken the name you want. Oh, and every time you buy a domain, a small fee goes to ICANN to keep things running smoothly. So in this case, the US no longer has to pay anyone to manage domains. Problem solved. But after a while, another issue popped up, one that could have broken the entire internet and made it unusable. In 2008, a researcher named Dan discovered that there is a massive problem going on with the whole domain name system. And if the solution to it was not found fast, it will lead to loss of millions of dollars, identity theft, massive data breach that will surely make the internet unsafe to use, and at the end of the day, render it useless. This exploit is called DNS cache poisoning. If you remember, the recursive server asks for the address of the name server that stores the IP of the website you want. Well, people figured out how to intercept the communication between the recursive server and the name server holding the real website address. They would then give the server a fake address that leads you to their website instead. Since they know what you're trying to access, they can create a website that looks exactly like the real one and steal your information. Imagine trying to log into your bank account and ending up on a site that looks identical to the real thing. Same domain name, same design, but it's fake. They grab your login details and drain your account. That's why this exploit is so dangerous. There's no easy way for you to know if the website is real or fake. ICANN eventually decided that every website on the internet must have 2 unique keys made up of characters. One of these keys stays secret, and the only device that knows it is the computer or server that hosts the website. This is called the private key. The second key can be known by any other computer on the internet, and it's called the public key. The whole point of these 2 keys is to keep information safe. Whenever data is sent over the internet, the computer sending it uses the website's public key to encrypt the details. Even if someone manages to intercept it, they won't be able to read the information, let alone figure out which site the sender is trying to reach. The only computer that can decrypt this information is the one that holds the private key, the intended recipient. This process is called public key cryptography, and it's the technology used to fix this huge problem.